Scientists claim that the universe began with an event known as the Big Bang, which occurred roughly 13.7 billion years ago. However, the lingering question is, what triggered that explosion and why did it happen? Over time, we've delved into the science and history of our universe, and the Big Bang theory has stood as the primary explanation for the phenomena we've observed. Numerous studies and countless scientists have worked on gathering research, and the collected data consistently supports the Big Bang theory as the principal explanation for how the universe came into existence. According to this theory, dark energy, a form of energy that is even more prevalent than galactic energy, is seen as the anti-gravitational force that has been driving the universe's expansion ever since the Big Bang. Science today is vastly different from what it was in earlier times, and with advances in technology, new theories emerge. Many times, we find that what we previously thought was entirely true is not the case at all. Michio Kaku has even proposed the formal debunking of the Big Bang theory, partly because the James Webb Space Telescope has detected 750 new galaxies that look completely different from what scientists had expected. This discovery presents a fresh perspective, encouraging us to investigate how the James Webb Telescope is reshaping our comprehension of the entire universe. Join us on this exciting journey beyond the observable universe as we explore the newly discovered galaxies in greater detail. If you're keen on staying updated with the latest universe-related news, subscribe to our channel, like this video, share it to reach a broader audience, and activate notifications for new updates. The images of new galaxies taken by the James Webb Telescope are simply breathtaking. In just one picture, we can observe hundreds of galaxies, and the magnificence and grandeur of these photographs are truly remarkable. Yet, what's astonishing to researchers is actually quite different from what might surprise the average person. While these images are inspiring to the scientific community, they don't align with the expectations based on the current theories. In fact, the number of galaxies observed is much higher than anticipated, and these galaxies are unlike others in that they are smaller than expected and exhibit ages far more remarkable than imagined. These surprises are sparking a sense of alarm among scientists, with even an article beginning with the word panic in its title, underscoring the gravity of the situation. These galaxies defy every prediction made based on long-standing theories. For many years, scientists proposed the Big Bang theory as the central explanation for the origin of our vast universe. According to this theory, around 13.7 billion years ago, the universe originated from a mysterious cosmic event. However, the newly captured images challenge the long-accepted narrative of the universe's birth. The images from the James Webb Telescope are shaking our understanding of the universe's origins, particularly since they seem to contradict the Big Bang theory, which has been regarded as an unquestionable fact by most cosmologists. The galaxies seen in these images are surprisingly small, smooth, ancient, and far more abundant than predictions based on the Big Bang theory had suggested. The observed galaxies are also 2 to 3 times smaller than those captured by the Hubble Space Telescope, which completely contradicts the expectations set by the expanding universe hypothesis. According to this theory, as the universe expands, objects should appear larger with increased distance. However, the galaxies observed by the James Webb Telescope appear to contradict that idea. Furthermore, the smoothness of these galaxies was not anticipated. According to the Big Bang theory, galaxies should display irregularities and structural variations due to the dynamics of their formation and evolution. However, the images show galaxies with unusually smooth structures, lacking the level of roughness and complexity that would typically be expected for galaxies of their age. This challenges the anticipated timeline for the formation and evolution of galaxies as envisioned in the context of the Big Bang theory. In the early universe, all matter, energy, and the foundational elements of the cosmos were compressed into an extremely dense point known as the singularity. At this moment, the density reached an infinitely high value due to the extreme compression of matter and energy. The concept of the singularity is rooted in our understanding of physics, particularly in Albert Einstein's general theory of relativity. Within this singularity, all the matter and energy of the universe existed in a highly concentrated form. The incredible density suggests that an immense amount of mass and energy was compressed into an infinitesimally small space under immense pressure and density. In such extreme conditions, the temperature inside the singularity would surpass any imaginable or measurable temperature we can understand today. Within this hot, dense point was the very origin of everything in the universe as we know it. The singularity marked the start of the cosmos from which everything emerged. After the singularity, the universe began its expansion and inflationary period, which occurred over approximately 13.7 billion years, ultimately giving rise to the universe as we observe it now. The expansion of the universe started with a rapid, enormous burst known as cosmic inflation. During this phase, the universe expanded far faster than the speed of light, stretching space itself and pulling everything along with it. Cosmic inflation played a pivotal role in forming the large-scale structure of the universe, smoothing out irregularities, equalizing the distribution of matter and energy, and setting the stage for the subsequent formation of galaxies, stars, and other cosmic structures. As the universe continued to expand, the rate of its expansion gradually slowed. It is important to note that while cosmic inflation was a brief period of rapid expansion, the universe continued expanding at a measurable rate, a process known as cosmic expansion. Scientists have studied the evidence of this expansion, including the redshift of light from distant galaxies. Redshift occurs when light waves stretch out as the universe expands, shifting them toward the red end of the spectrum. During the expansion, all the matter that makes up the universe was compressed into an extremely small volume. It became apparent that matter could not survive in such a compressed state, so transformations took place as the universe expanded and cooled. In this early phase, particles like protons, neutrons, and electrons began interacting with light and energy, which played a crucial role in the formation of matter in the universe. During the first minutes following the Big Bang, this process, called nucleosynthesis, involved the creation of basic elements. Chaotic and disrupted galaxies formed by multiple collisions were expected to be observed. But the James Webb images present a different narrative. Instead of chaotic, colliding galaxies, the telescope captures well-organized disk-like and spiral-shaped galaxies, similar to the ones we see in the present-day universe. This unexpected finding challenges the assumption that mergers are a fundamental part of galaxy evolution. If these galaxies have not undergone many or any mergers, it becomes unlikely that small galaxies would grow into massive structures as originally predicted. This suggests that these galaxies might have always been larger than expected. Additionally, the optical illusion predicted by the expanding universe theory, where objects appear smaller due to cosmic expansion, does not hold true in this case. Thus, many of the concepts we previously held to be true may no longer be accurate. The age and abundance of galaxies revealed by the James Webb Telescope also cast doubt on the validity of the Big Bang theory. The James Webb Telescope is equipped with filters that allow it to capture images in the infrared spectrum, which enables astronomers to analyze the colors of distant galaxies. By studying these colors, scientists can estimate the age of stars and galaxies. If you enjoyed this video, please hit the like button, share it with others, and subscribe to the channel to stay informed about our future videos. The findings from the James Webb Space Telescope, JWST, represent a significant leap forward in our understanding of the universe. Its ability to observe distant galaxies with unprecedented clarity allows scientists to gather data that challenges existing models of cosmic evolution. The JWST's sensitivity to infrared light has allowed it to peer deeper into the universe than ever before, revealing objects that were previously beyond reach. These discoveries are reshaping our understanding of the universe's early stages and forcing a reevaluation of established theories like the Big Bang. One of the key implications of these findings is the possibility that our understanding of galaxy formation and the early universe might need to be rethought. The conventional idea of chaotic, irregular galaxies evolving from mergers and collisions may not be as accurate as once believed. The smooth, organized structure of many of the galaxies captured by the JWST suggests that the process of galaxy formation could have been far more orderly than previously imagined. This raises new questions about the mechanisms that drive the formation and evolution of galaxies in the early universe. Another intriguing discovery is the apparent age of these galaxies. The JWST observations suggest that some of these galaxies are much older than expected, which contradicts the Big Bang model's predictions. According to the Big Bang theory, galaxies and stars should have taken billions of years to form and mature. However, the images from the JWST suggest that these galaxies could be much older than anticipated, which challenges our understanding of the timeline of the universe's development. If these galaxies are indeed as old as the data suggests, it could mean that the formation of galaxies occurred much earlier in the history of the universe than previously thought. The presence of such old and well-formed galaxies so early in the universe's history is a major puzzle. It forces scientists to reconsider the processes that allowed for such rapid galaxy formation. The standard model of the universe's evolution suggests that galaxies formed gradually over billions of years, but the JWST's findings seem to indicate that some galaxies formed much faster than expected. This has profound implications for our understanding of how the universe evolved and the role that dark energy and other cosmic forces may have played in shaping it. The unexpected discoveries made by the James Webb Telescope are not only reshaping our understanding of the universe's past, but they are also opening up new possibilities for future research. As scientists continue to analyze the data, they will likely uncover even more surprising details about the origins and evolution of the cosmos. These findings suggest that the universe is far more complex and dynamic than we ever imagined, and they highlight the need for new theories and models to explain the vast array of phenomena that are emerging. As technology continues to advance, it is likely that new telescopes and instruments will provide even deeper insights into the universe's mysteries. The JWST is just the beginning of a new era in space exploration, and its discoveries will undoubtedly lead to many more breakthroughs in our understanding of the cosmos. The future of cosmology is full of exciting possibilities, and the ongoing research will undoubtedly provide answers to some of the most profound questions about the universe's origins and its ultimate fate. In conclusion, the James Webb Space Telescope has already begun to challenge some of the most fundamental ideas about the universe. Its discoveries of new galaxies that defy the predictions of the Big Bang Theory are forcing scientists to rethink everything they thought they knew about the cosmos. These findings are pushing the boundaries of our knowledge and opening up new avenues for exploration. As we continue to study the data from the JWST and other future missions, we may uncover even more surprising revelations about the universe and its origins. The journey of discovery is just beginning, and the answers to the universe's deepest mysteries may be closer than we think. The discoveries made by the James Webb Space Telescope, JWST, have opened up a new chapter in the study of the cosmos. The level of detail in its images and data is extraordinary, revealing previously unseen aspects of the universe that challenge long-standing theories. These revelations suggest that the universe may have a more complex and multifaceted history than we have understood up until now. The JWST's capabilities allow it to probe deeper into space and time, unlocking the potential to answer some of the most profound questions in cosmology. One of the most significant aspects of these discoveries is the way in which they complicate the Big Bang Theory. For decades, this model was considered the most reliable explanation for the origin of the universe. Yet, the recent findings of galaxies that are older, smaller, and smoother than expected raise serious doubts about its accuracy. The fact that the JWST has uncovered these galaxies, which appear to be far more mature than anticipated, suggests that the processes that led to their formation might have occurred in a different way from what we've assumed. This directly challenges the idea that galaxies formed gradually over billions of years through mergers and collisions. The implications of these new discoveries stretch beyond just the Big Bang Theory. They raise fundamental questions about how we understand the universe's formation, its expansion, and the processes driving cosmic evolution. If the galaxies observed by the James Webb Space Telescope, JWST, are indeed much older than expected, it could imply that galaxy formation was far quicker and more efficient than previously thought. This challenges the long-held notion that galaxies developed gradually through a series of mergers and interactions, which suggests that other mechanisms might have been involved in their early formation. Moreover, the fact that these galaxies are smaller than expected further complicates our understanding of how galaxies grow over time. According to the prevailing models, galaxies should be much larger at earlier stages of the universe due to the cumulative effects of mergers and gravitational attraction. However, the relatively small sizes of these galaxies, combined with their high age, point to a need for a reevaluation of how matter in the early universe condensed into these structures. One of the more perplexing aspects of these findings is the unexpected smoothness of the galaxies observed. In many current models, it is predicted that the early universe was filled with turbulent forces that created irregular structures and chaotic galaxy formations. However, The images from the JWST show galaxies that appear far more orderly and uniform. This lack of complexity raises new questions about the forces and processes that govern galaxy formation, which may not align with the typical predictions based on existing cosmological models. The newfound details about these galaxies also point to the possibility that dark matter or other unknown forces may have played a larger role in the universe's evolution than we previously understood. The role of dark matter, which is believed to make up a significant portion of the universe's total mass, is still not fully understood, and the latest discoveries may shed new light on its influence on early galactic structures. As scientists continue to analyze the data from the JWST, new avenues of inquiry will emerge, prompting more experiments and theories to explain the vast and mysterious nature of our universe. The implications of these findings will ripple throughout cosmology, physics, and astronomy, driving future exploration and inspiring a whole new generation of scientific inquiry.